Electrical work should always be performed by a qualified electrician. When dealing with splicing aluminum to copper wires, it's important to use the correct materials and techniques to ensure a safe and reliable connection. Here's a breakdown of how to properly splice stranded number 8 aluminum wire to solid number 10 copper wire. Firstly, gather the necessary materials. You'll need wire nuts specifically designed for aluminum to copper connections, electrical tape, and a wire stripper. Before starting any electrical work, always prioritize safety by turning off the power. Ensure that the breaker for the circuit is turned off to prevent electrical shock. Next, remove the old wire nuts from both ends of the damaged wires, taking care to avoid touching any exposed conductors. Use the wire stripper to strip approximately 3/4 of an inch of insulation from the ends of both the aluminum and copper wires. This will expose the bare conductors needed for the connection. Since the aluminum wire is stranded, twist the strands together to form a solid bundle. This helps ensure a more secure and reliable connection. Now take an aluminum to copper wire knot and place it over the twisted aluminum conductors. Tighten the wire nut securely using pliers, making sure it's snug but not over-tightened. Over-tightening can damage the wires or the wire nut. After securing the aluminum wire, wrap the stranded aluminum wire around the solid copper wire several times. Ensure that the strands make good contact with the copper to create a strong electrical bond. Place a second aluminum to copper wire knot over the wrapped wires and tighten it securely. This will further reinforce the connection and provide additional insulation. To further insulate the connection, apply 2 layers of electrical tape. Wrap the tape tightly and evenly to cover all exposed conductors and the wire nuts. Use cable ties or electrical tape to secure the wires to the junction box. This will prevent them from moving around and potentially loosening the connection. Once you've completed all the steps and double-checked your work, turn the breaker back on to restore power to the circuit. It's also a good idea to use a wire brush to clean the contact surfaces of the wires before making the connection. This will remove any dirt or corrosion that could impede the flow of electricity. Make sure the wire nuts are tightened securely but not over-tightened. If the stranded aluminum wire is too soft to wrap around the solid copper wire, a crimping tool can be used to make a secure connection. Always consult the manufacturer's instructions for the specific aluminum to copper wire nuts you are using. They may have specific recommendations or requirements for installation. Understanding the different types of wire nuts is crucial for safe and effective electrical connections. Standard wire nuts are designed for copper-to-copper connections only. Using them with aluminum wires can lead to corrosion and fire hazards. Aluminum to copper wire nuts are specifically designed to accommodate the different expansion and contraction rates of aluminum and copper, preventing loose connections and corrosion. These wire nuts typically have a special compound inside that inhibits corrosion. Furthermore, proper grounding is an essential safety measure in electrical systems. The ground wire provides a path for electricity to flow back to the source in the event of a fault, preventing electrical shock. Ensure that the ground wire is properly connected to the junction box and the equipment it's serving. Before working on any electrical circuit, it's important to understand the circuit's voltage and amperage. This information can be found on the breaker panel or in the electrical diagrams for the building. Using the wrong size wire or breaker can overload the circuit and create a fire hazard. Always use the correct size wire and breaker for the circuit's intended load. The National Electrical Code, also known as NEC, provides comprehensive guidelines for safe electrical installations. It covers everything from wire sizes to grounding requirements to overcurrent protection. Familiarize yourself with the NEC requirements for your area before starting any electrical work. When working with aluminum wire, it's important to be aware of the potential for oxidation. Aluminum oxide is a poor conductor of electricity, so it's important to remove any oxidation before making a connection. Use a wire brush or a special antioxidant compound to clean the aluminum wire before connecting it. In addition to wire nuts, there are other types of connectors that can be used to splice aluminum to copper wires. These include crimp connectors, split bolt connectors, and compression connectors. Each type of connector has its own advantages and disadvantages, so it's important to choose the right connector for the application. Also, regularly inspect electrical connections to ensure they are still tight and secure. Loose connections can cause arcing and overheating, which can lead to a fire. If you find any loose connections, tighten them immediately. When replacing a damaged wire, use the same type and size of wire as the original. Using a different type or size of wire can create an imbalance in the circuit and potentially overload it. When working in a junction box, make sure the box is properly sized for the number of wires and connectors it contains. Overcrowding a junction box can make it difficult to make connections and can also create a fire hazard. Consider upgrading to a larger junction box if necessary. The insulation on electrical wires is designed to protect against electrical shock and prevent short circuits. If the insulation on a wire is damaged, it should be repaired or replaced immediately. Electrical tape can be used to repair minor damage to insulation, but severely damaged wires should be replaced. Surge protection is another important safety measure for electrical systems. Surge protectors protect electronic equipment from damage caused by power surges, which can be caused by lightning strikes or other electrical events. Consider installing surge protectors at the breaker panel and at individual outlets. Ground fault circuit interrupters, also known as GFCIs, are designed to protect against electrical shock. They detect small imbalances in the current flowing through a circuit and quickly shut off the power. GFCIs are required in wet locations such as bathrooms and kitchens. Arc fault circuit interrupters, also known as FCIs, are designed to protect against fires caused by electrical arcs. They detect the unique characteristics of electrical arcs and quickly shut off the power. FCIs are required in many areas of the home, such as bedrooms and living rooms. When working with electricity, always wear appropriate personal protective equipment, including safety glasses and rubber gloves. This will help protect you from electrical shock and other injuries. Never work on electrical equipment when you are tired or distracted. It's important to be alert and focused when working with electricity to avoid making mistakes. Always double-check your work before turning the power back on. Make sure all connections are tight and secure and that there are no exposed conductors. If you are not comfortable working with electricity, it's always best to call a qualified electrician. They have the knowledge, skills, and experience to safely and effectively perform electrical work. Remember that electrical work can be dangerous, so it's important to take all necessary precautions. By following these safety tips and using the correct materials and techniques, you can safely and effectively splice aluminum to copper wires. First, the materials need to be prepared, which includes aluminum to copper-rated wire connectors, which often have an antioxidant paste within them. Secondly, wire strippers are needed to remove insulation without damaging the conductor. Thirdly, electrical tape rated for the voltage of the connection to provide an insulating barrier. Fourthly, pliers or wire crimper, depending on the type of connector being used to ensure a secure mechanical connection. Fifthly, a voltage tester to verify the circuit is de-energized before starting work. Sixthly, a wire brush to clean the conductors and remove oxidation. Now for the steps. Firstly, turn off the power at the circuit breaker to ensure no live current is flowing through the wires. Secondly, use a voltage tester to confirm the circuit is de-energized before touching any wires. Thirdly, carefully remove the burnt or damaged section of the wires, ensuring a clean cut to expose fresh conductor. Fourthly, use a wire stripper to remove approximately 3/4 of an inch of insulation from both the aluminum and copper wires. Fifthly, clean the exposed conductors with a wire brush to remove any oxidation or debris, ensuring a good electrical contact. Sixthly, if using wire connectors, firmly twist the aluminum and copper wires together in a clockwise direction, then screw on the connector until it is secure. Seventhly, if using crimp connectors, insert the wires into the connector and use a crimping tool to create a tight, permanent bond. Eighthly, wrap the connection with electrical tape, overlapping each layer to provide complete insulation. Ninthly, neatly place the spliced wires back into the junction box, ensuring they are not overcrowded or stressed. 10thly, screw the cover back onto the junction box. 11thly, turn the power back on at the circuit breaker. 12thly, test the circuit to ensure it is working correctly and safely. Here are some additional things to keep in mind. Always use connectors that are specifically rated for aluminum to copper connections to prevent galvanic corrosion. Consider using a pigtail method where a short length of copper wire is connected to the aluminum wire using an aluminum to copper rated connector, and then the copper pigtail is connected to the existing copper wiring with a standard copper to copper connector. Regularly inspect the connection for signs of corrosion or overheating, and retighten or replace connectors as needed. It is very important to follow all local electrical codes and regulations, or consult with a qualified electrician for assistance. Consider the long-term reliability and safety of the connection, as aluminum to copper splices can be prone to failure if not done properly. Educate yourself about the specific properties of aluminum and copper wiring and how they interact when spliced together. Invest in high-quality connectors and tools to ensure a professional and long-lasting result. Be aware of the potential hazards of working with electricity and take all necessary precautions to protect yourself and others. Stay up to date on the latest electrical safety standards and best practices. If you are unsure about any aspect of the splicing process, seek guidance from a qualified electrician before proceeding. Remember that electrical work can be dangerous, so it is always better to be safe than sorry. Consider using antioxidant paste on the aluminum wire before making the connection to prevent corrosion. Use a torque screwdriver to tighten the connectors to the manufacturer's specified torque to ensure a secure and reliable connection. Label the junction box to indicate that it contains an aluminum to copper splice. Keep a record of the date the splice was made and the type of connectors used for future reference. Periodically check the temperature of the junction box with an infrared thermometer to detect any signs of overheating. Provide adequate ventilation around the junction box to prevent heat buildup. Protect the junction box from moisture and physical damage to prevent corrosion and electrical hazards. Use a lockable junction box cover to prevent unauthorized access to the splice. Consider using a surge protector on the circuit to protect against voltage spikes that could damage the connection. Use a ground fault circuit interrupter (GFCI) outlet on the circuit to protect against electrical shock. Install a smoke detector near the junction box to provide early warning of a fire. Develop an emergency plan in case of an electrical fire, including how to safely shut off the power and evacuate the building. Make sure everyone in the household knows how to shut off the power in case of an emergency. Store flammable materials away from the junction box to prevent them from igniting in case of a fire. Keep the junction box clean and free of debris to prevent overheating and electrical hazards. Regularly inspect the wiring in the junction box for signs of damage or wear, such as frayed insulation or loose connections. Repair any damaged wiring immediately to prevent electrical hazards. Use a wire management system to keep the wires neatly organized in the junction box. Consider using a thermal imaging camera to inspect the junction box for hot spots that could indicate a problem. Use a calibrated ammeter to check the current flow through the wires in the junction box to ensure they are not overloaded. Consult with a qualified electrical engineer to design a safe and reliable aluminum to copper splice for your specific application. Use a high-quality digital multimeter to accurately measure voltage, current, and resistance in the circuit. Properly terminate the ground wire in the junction box to provide a safe path for fault current. Clearly label all wires in the junction box to prevent confusion and errors during future maintenance. Use a wire gauge tool to accurately measure the size of the wires in the junction box. Use a wire pulling lubricant to make it easier to pull wires through conduit. Use a fish tape to route wires through walls and ceilings. Use a knockout punch to create clean, round holes in the junction box for conduit connectors. Use a conduit bender to bend conduit to the desired angle and shape. Use a thread cutting tool to create threads on conduit for connecting fittings. Use a pipe wrench to tighten conduit fittings. Use a level to ensure that the junction box is installed plumb and square. Use a stud finder to locate studs in the wall for mounting the junction box. Use a drywall saw to cut a hole in the wall for the junction box. Use a screwdriver to install the junction box cover. Use a drill to create pilot holes for screws. Use a hammer to drive nails or staples. Use a ladder to reach high places. Use a flashlight to illuminate dark areas. Use a first aid kit to treat minor injuries. Use a fire extinguisher to put out electrical fires. Call 911 in case of a serious electrical emergency. Always remember safety first when working with electricity.